Good morning to all. Today I am discuss about the topic formation of LPP and graphical method. Graphical method. The introduction. The linear programming method is applicable problems characterized by the presence of decision variable, the objective function, and the constraints can be expressed as a linear function of the decision variable. Graphical method procedure. First one is graphical method in LPP can be used to solve having only two decision variables. Second one is since the graph has two axes, select one axis, each two represent one decision variable. The constraints are represented as straight lines on the graph. Each constraint be represented by one line. Fourth one is take the first constraint, consider it only as an equation, ignoring the portion in the constraint. May y equal or to 0. Fifth one is join 2 points on the x-axis and y-axis by the straight line. Then determine taking the values x or y less than or greater than the points x or y axis. Identify all the corners of the feasible region and name the A, B, C, etc. Okay. Indicate the optimum solution of the problem giving the values decision variable x, y and the corresponding value of the objective function. Problem. Suppose an industry is manufacturing two types of product P1 and P2. The profit is per kg of the two products rupees 30 and rupees 40 respectively. These two products require processing in three types of machines. The following table shows the available machine hours per day and per required on each machine to produce kg of P1 and P2. Formulate the problem in the form of linear programming model. Machine 1, machine 2, profit rupees 30, profit rupees 40 total. And first you let x1 equal to amount of P1, x2 equal to amount of P2. Then the following concept to find the equation 3x1 plus 2x2 less than or equal to 600. Similarly, 3x1 plus 5x2 less than or equal to 800. 5x1 plus 6x2 less than or equal to 1100. Now x1 greater than or equal to 0, x2 greater than or equal to 0. The product mix problem in the linear programming model is maximum 30x1 plus 40x2 subject to 3x1 plus 2x2 less than or equal to 600. 3x1 plus 5x2 less than or equal to 800. 5x1 plus 6x2 less than or equal to 1000, 1100, x1 greater than equal to 0, x2 greater than equal to 0. And change the LPP. Then next one problem, a company purchasing scrap material has two types of scrap materials available. The first type has 30% of material, 20% little. Second type is 40%, 10%, 30%. The cost of 120, 160, 240, 1000 kg to 290 kg. So that the company recommends three metal satisfied minimum cost. Minimum cost mean this problem is minimum 1200 plus 160 and multiply both side by 10. The minimum 120 x1 plus 160 x2 subject to the constraint. Then the procedure. Then plotting all the points in the graphs x1, x2. Then to find the graph 3 graphs 3x1 plus 4x2 is greater than equal to 2400. Another one graph is 5x1 plus 3x2 greater than equal to 2900. 2x1 plus x2 greater than equal to 1000. The optimum solution A, B, C, D to find the value x1 equal to 400, x2 is equal to 300, and the maximum z equal to 96000. Therefore, the minimum substitute function of the problem contains multiple optimum solution. Thank you.